Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Exploring Logarithmic Functions. If you have watched some of my videos, you probably have seen recently that I did a video on exponential functions. Okay, for example, y equals 3 to the x. And I'm going to go ahead and give that a graphical view. Now we know that we're raising to a power, and if you'd watched this video, you would have saw we have a horizontal asymptote at 0, because this will never actually hit 0. Because we're timesing by 3, timesing by 3, timesing by 3, or dividing by 3, depending on whether you're going forward or backwards. So 3 to the 0 power is 1, 3 to the first is 3, 3 to the second is 9, 3 to the negative 1 is a third, then a ninth, then a 27th. And so we're getting this exponential growth function. And again, I'll just go ahead and put those ordered pairs out here. Negative 3 was 1/27th. Negative 2 was 1/9. Negative 1 is 1/3. 0 is 1. 1 is 3. 2 is 9. 3 is 27. And if you look at our y values, you can see that multiplying by 3 each time. When it comes to logarithmic functions, logarithmics are the inverse of exponential. So if you watched my how to calculate the inverse video, you would have known the first thing we do is we switch our x and our y, and then we get y by itself. In this case, y is in the exponent, so we have to isolate an exponent by using logs. So we'll have our exponent equals log base 3 of our x. And these ordered pairs are going to be backwards because we switched the x and y. We'll be switching the x and y, or inverting the exponential function. So 1/27th will be negative 3, 1/9 will be at negative 2, 1/3 will be negative 1, 1 will be at 0, 3 will be at 1, 9 will be at 2, and 27 will be at 3. So 1, 0 is pretty easy to do. 2, 3, 1, 4, 5, 6, 7, 8, 9 is at 2. A third is at negative 1. A ninth is at negative 3. Okay, so we can see a couple things. Because there was a horizontal, a y equals 0 asymptote before, now we have an x equals 0 asymptote. And the asymptotes are important if you're drawing the graphs. And as always with inverse functions, they must perfectly reflect across this line y equals x, which they do. If I can draw a straight line, there we go. So when we're looking at exponential functions, they really are just the reciprocal, or not the reciprocal, the inverse of logarithmic functions. And so they mirror each other. So for exponential functions, our domain is negative infinity to infinity, and our range is 0 to infinity. Well, because x and y are flip-flopping, over here our domain is 0 to infinity, and our range is negative infinity to infinity. Now, if you've been following this channel for a while, you've seen that I've done a lot of HK shifts, and that's exactly what you're going to find yet again in logarithmic functions. For any y equals log base b of x, okay? You're still going to have a stretch factor. I like to write log in cursive so it doesn't look like 10g. You're still going to have your h k shifts. So you're right, left, and you're up, down. So all that's going to hold true still. So if I see y equals log base 4 of x minus 8 minus 2. This is right 8 down 2 from the parent function, which would have been log base 4. And because it's to the right 8, and we have vertical asymptotes, the vertical asymptote will be at x equals 8. Okay, so those HK shifts are really going to play a role into it. And so we should be able to identify shifts by this point. If you've been watching all my videos, it's always the opposite of what's going on because it's what zeroes this out. So positive 8 zeroes that out. And this is just reinforcing that HK shifts, and then we're going to reinforce the inverses. So let's think about that. Let's try another inverse type thing. What if we have f of x equals 3 times 10 to the x plus 2. So this is an exponential form. Remember that really what this is saying is y equals 3 times 10 to the x plus 2. So first step for inversing is we're going to switch that x and y. So as we're doing this, we have to get this by itself first because this has to not have a coefficient. So that's what we're going to do is divide by 3. And sometimes I think about it like this. We have PEMDAS, right? We have a multiplier and we have an exponent. So when you're working backwards to solve, you get rid of those in reverse order. Whatever the order of operation is you would have done, that's what you do in reverse. So we're going to get rid of multiplying first by dividing, or I can multiply by 1/3. That's the same as dividing by 3. Okay, now we need to get rid of that exponent because that's where our variable is. This should be a y. So our variable's right there. So we're going to write our power equals log. We need our subscript. And then that 1/3 x or x over 3, either way, goes inside. Now since this is base 10, that's common log. And common log is just assumed, and you do not actually have to write base 10. So then once we do that, we're going to subtract 2. Whoa. You can have it that way as well. So really, you're just switching your x and y, isolating your y. What if we start in log form and we need to get the inverse? Okay. F of x equals log base 4 of x minus 8. I'll write y this time, I promise. So we get switch them, x equals log base 4 of y minus 8. So we have the parenthesis, but we have the log out here. So we need to reformat because it's already logged down, and we need to basically, you know, instead of taking the tree down, let's put the tree back up. So my base was 4, x was my power, and that's going to equal y minus 8. And now we can add 8. You can always check these by making sure that the two graphs fold on the line y equals x. Graph this one and graph this one if you have a graphing utility. Make sure they fold perfectly. Make sure the ordered pairs work out. This one has been moved to the right 8. So this one has a vertical asymptote of x equals 8. This one has a horizontal asymptote of y equals 8 because your x becomes y. Okay. So one last one just to make sure we've got it. Make this one a little, actually we'll do one more of each kind. Make them a little more complicated, just to make sure we can do our inverses. F of x equals 5 times 3 to the x minus 2 plus 1. And then we're also going to do g of x equals 4 log base 2 of x plus 3 minus 8. So if you want, pause the video and then try them on your own and then see how you did. Otherwise, I'm going to go through F first and then G. So switch my X and my Y. Okay, reverse that order of operation, so I got to get rid of that plus 1 first. Then I got to get rid of multiplying and dividing, so I'll divide by 5. Now my power has the variable that I want to get isolated, so I need to put it in log form so I can get this y minus 2 down. Base 3, and we have a fraction inside here, and that's okay. And then we'll add 2. So the inverse of f is log base 3 of this quantity plus 2. How'd you do? Did you beat me there? Okay, let's try G. Switch my variables. I'm trying to get y by itself. I have subtracting and multiplying. Order of operations say you multiply first and subtract later, so when we're solving, we work backwards. Get rid of that 8. Now I'll get rid of the multiplying. That y is stuck inside the log, so I need to reverse the log process. To reverse the logging process, you rebuild the tree, right? Instead of knocking the tree down, put the tree back up. So our base is 2. Our power is this fraction. And that equals what's inside. So that means G inverse is going to be 2 to this fraction. And we'll subtract the 3 over. So really, this was mostly just making sure you understand about the fact that these graphs really are inverses of exponential graphs, and then making sure you can go from an exponential to the log inverse, or go from a log to its exponential inverse. Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.